Okay, we are back for our last chemistry squad, actually, of this academic term and actually of this academic year. So my name is NK, as usual, and we're back for another chemistry squad. Today we're just going to be going over a past paper that we started off last week. I think it was, I cannot remember whether it was AQA or EdXL. I think it was EdXL, so I'm going to pull up an EdXL past paper really shortly. We'll go over a few questions, and then really what I then want to do is then just sort of spend a bit of time answering any questions that anyone may sort of have. Um, since we're getting towards the end of the academic year, I'm sure all of you at some point have done some mock exams. You may have gotten some results from these mock exams, and some of them may be good results. Some of them may not necessarily be as high as you want, but that's fine because one of the key things to take away from any mock exam that you do in school is to reflect. Reflect on how you prepared for it, whether you prepared adequately or whether you didn't really prepare adequately, and then what sort of measures you can then put in place for the next mock or the next actual exam. But we'll just get started really. We'll wait for a little bit just for a few more drifters to join us. And yes, this will actually be the last chemistry squad of this academic year. It's been really, really exciting, been really, really fun. I've loved all the engagement so far. And hopefully my tutor do another run of these squads next academic year as well. Hi Mohammed, how are you? It's good to see you again. You already have a question. I think I'll answer it now while we just sort of gear up to get started. Can a person go up 3 grades for a subject? I think that's a very good question. I think this really depends on what the subject is. It depends on whether or not you think, or whether the person in particular finds that subject easy. And I also think it depends on why they got the grade that they got in the first place. So I guess this sort of echoes my initial point about reflection after a set of mock results. Let's just take chemistry, for instance, and the reason I'm going to take chemistry is because that's what we're going to be talking about today. If you, let's say you did a mock exam, and let's say you got a grade 5, for instance, and you wanted a grade 8. I'm going to use a gap of 3 here, since you mentioned, is it possible for someone to go out with 3 grades? I think the first thing to sort of ask yourself is, okay, well, why did I get a grade 5 in the first instance? So if you have the opportunity to have a look at that past paper and see where you got some of those marks and see where you lost some of those marks, was it a case of a lack of understanding of the content? Was it exam technique? Was it a little bit of both? Answering those questions is really your first step to then determine how you go about going up a grade or 2 grades or 3 grades. So let's say, for instance, you get your mock results, and actually you realise upon reflection that I didn't really prepare for it at all. Well, then you've answered your own question. You didn't prepare for it, and therefore you may not have known the content that you needed to know for that mock exam. So if that's the case, then you then know what to do next time. You then know to prepare adequately next time. Maybe make revision notes in a good amount of time before the actual exam. Don't wait until you're told you have an exam. Prepare regularly throughout the year. So to answer your question, Mohammed, I think it is entirely possible for someone to go up 3 grades for a subject. I think it depends on, it is worth sort of thinking about why you got the grade that you got in the first instance, and then it's all about whether or not you then put measures in place to actually progress. That's what I would say personally. That's the sort of advice that I would give. It's not necessarily a blanket statement. It just really depends on the circumstances, around that initial mock grade. But I can see a few people have joined us. Don't be afraid to say hello. It's great to see you all. Again, this is our last chemistry squad. One thing I will say as well is that there is a link in the description to give feedback. Here at my tutor, all these resources, all these live streams, any events that we put together, they are all for you as students. And so if you don't give us feedback, we don't know what you find useful, and we don't know, what resources that we can put together to support you in your progression. So the more feedback you give us, the better, whether it's something that you like, whether it's something that you don't really like, whether it's something that you think we can improve on. Again, any feedback is useful feedback for us. So I do encourage you to click on the link in the description to this video, and you just type as much feedback as you want. Also, if you do like this video, do make sure to smash that like button as well, because it gives us at My Tutor a good understanding of what you do like and what you don't like. If you are interested in this chemistry squad and you didn't get a chance to tune in live to the other ones, that's all okay. They are all on the My Tutor YouTube channel, so you can always go back and rewatch them if you want to, just for your own independent revision. Now, at the end of each series of study squads, I always get the question, are there going to be more, or they're not? And I don't really know, to be honest, but the more you give feedback, the more you like these videos, the more you share these videos, the more we at My Tutor know that you like these squads, and therefore we know to put them together and to get new tutors in, and really zhuzh it up for the next round. So that's what I would say anyway. But I think it would be a great opportunity to now start with going over that Edexcel past paper. So I am just going to pull this up. I was on the AQA page before, so I'm just going to move over to Edexcel. Again, I think I'm going to use the session just to go through the past paper, just give a little bit of tips and tricks when it comes to doing these past papers. But I'll also just give all of you the opportunity to ask as many questions as possible. So this is going to be a bit of an exam technique, but also a bit of a Q&A session. So by all means, just utilize the opportunity. Okay, so I think we were doing 2021, June 2021. So I'm just going to pull that one up. Now, as you probably know, I access all these past papers off a website called Physics and Maths Tutor. It is a very, very good website. I'm a tutor on the My Tutor platform, and I quite like it because everything's free to access. It's really easy to find links to things, and I share those with my students. So from that perspective, I think it's a really, really good resource. That being said, you can access all these other past papers through the exam board itself. So if you do Edexcel, then I would say go to the Edexcel website. If you do AQA or OCR or WJEC or any other exam board, CIE, for instance, like the Cambridge International Exam Board, then by all means, do make sure you know how to navigate your exam board website. Other bits of advice that I would give when it comes to using past papers, examiners' reports, I think they're quite often forgotten about, but I think they're a really good resource because they give students a real opportunity to have a good understanding of what it is the examiner likes and what it is the examiner thinks, okay, this cohort could have improved on this. Okay, so even after you've done a past paper, even after you've marked it, do take advantage of the examiner's reports. A lot of them are free to access. Not all of the past paper series are free to access because some of them are locked. But I'm sure if you looked around enough, I'm sure you'd be able to find them because there are loads of like forums and stuff like the student room, etc. So yes, by all means. So we went through this part of the question already. So again, if you want to go back and look at the previous parts of this past paper, then do check out the previous video on the My Tutor YouTube channel. I think we were here all about question 4, and this one is all about aluminium and alloy, so it will also be a great opportunity to do some revision of some of the things that we may have covered in this Chemistry Squad series or in a previous Chemistry Squad series, so by all means. So question 4, aluminium alloys are used instead of pure aluminium in aircraft manufacture. Explain in terms of the arrangement of metal particles why aluminium alloys are stronger than pure aluminium. Really interesting question. It's 3 marks. What do we think? Let's get some ideas going on in chat. What are some ideas here? Why do we think that pure aluminium isn't really used, but alloys of aluminium are used instead when we think about aircraft usage? It's a 3 marker. So what we really want to do is think a little bit about, what sort of points can we make? sort of get those 3 marks in this exam. Okay, so Mohammed, I can see you have given an answer, a really in-depth answer too, so that's great. Aluminium pure is in regular shape, so it can slide over each other, whereas an alloy can't slide over each other because it's disrupted by another metal, so it's in an irregular arrangement. Okay, so I would definitely agree with that. I think that's a very good way of highlighting the differences between an alloy and a pure metal. I'm going to pull up the mark scheme just to see how many marks you would get here. I am inclined to think that you'd get 2 marks here. I think it's a very good answer. You definitely said the right things, but I'm likely to think you get 2 marks there. And the reason that I say you'd get 2 marks is just because the one thing I would have added on is just a statement that relates the science that you have stated back to the question. So if we're thinking about how we want a metal to be used in an aircraft, what sort of properties do we want the aircraft to have? We want it to be strong. Maybe we want it to be resistant to, like strong forces. If you think about strong winds, for instance. And so I think the point there is that because the metal ions in your alloy can't slide over each other because you've got different sizes of metals and atoms, and therefore layers can't slide over each other, that makes it stronger. And I think just that statement that it makes the substance stronger is probably what you may need to get the mark. So let me have a look here. I might be just being a half examiner, but we'll see. So 1 mark for saying in pure aluminium, all the atoms are the same size, whereas in an alloy, atoms are of different sizes. So that's 1 mark actually. So actually stating why the alloy layers can't slide over each other. And then in the 2nd mark for saying that in aluminium, the layers can easily slide over each other, but then in an alloy, they can't slide over each other as easily. So actually, I think still 2 marks. So I think the reason that you wouldn't have just gotten that last mark there is just because you wanted to say explicitly that the reason that in your pure metal, the layers can slide over each other very easily is because there's regularity, okay? Because the atoms can slide over each other, whereas you have irregularity in the case of your alloy because the different substances are different shapes. So your different atoms or ions are different shapes. And the reason that I say atoms or ions is because remember that an alloy isn't always just a metal and a metal. An alloy can also be a metal and a non-metal. A really good example that you learn about at GCSE is steel. Steel consists of iron, which is your metal, but also consists of carbon, which we know to be a non-metal. Okay, so just these little minor things make a huge difference as to whether or not you pick up all those marks or not. But otherwise, really good answer, Mohammed. Well done for sharing that. Okay, right, let's move on to the next question. A 695 gram sample of aluminium magnesium alloy contains 2% by mass of magnesium. Calculate the mass of aluminium in this sample. So what do we think we would get here? Right, we've been given the mass, or the percentage by mass of magnesium. We want to know about aluminium. Okay, so we said 0.02 times 695 gives you 13.9. Okay, so interesting there. The correct answer here is actually 681.1 grams. Okay, and actually, I immediately knew when you did that calculation where exactly a lot of students will lose the marks here. So let's go back to the question and reread it. A 695 gram sample of aluminium magnesium alloy contains 2% by mass of magnesium. Calculate the mass of aluminium in this sample. Okay, now the question is asking us about aluminium, but actually in the question they have told us about magnesium. So we know that this alloy consists of 2 metals. It consists of aluminium and magnesium. So there are only 2 substances. If they've told us in the question, okay, that the percentage of magnesium in this alloy is 2%, then that must mean that the percentage of aluminium must be 98%, because we know that actually you only have the two components there. So there are two different ways in which you could actually answer this question, and you'd get the right answer in both instances. Since you know that the aluminium must make up 98% of the alloy, you could do 0.98 times 695, and that would give you 681.1 grams. Alternatively, if you wanted to do the reverse, where you calculate the mass of magnesium in this alloy, which we know to be 13.9, we could then subtract 13.9 from 695 grams. Okay, and if we were to do that, that would also give us 681.1 grams. One question that I think a lot of students would ask here is, well, which one is the better way? And the short answer is neither is inferior or superior to the other. What I would say, though, is I personally prefer the first way, because the first way almost ensures that I'm not going to skip anything out. I think instinctively with this question, you see 695 grams, 2%, and calculate. And immediately you jump to doing 2% of 695. But actually, you don't want that. You want the other components. You want the 98%. And if I figure out that, okay, well, 2% is magnesium, therefore 98% is aluminium, then I know I can just focus on that 98%. Okay? Loads of different ways in which you could address this question. Okay? I would say no way is better than the other way. I think, as is the case with any type of calculation in chemistry, it's super, super important that you just go over your questions. So, Mohammed, you've asked whether we can move quicker onto other questions. What I would say is, whilst it's great that you're on the ball, just in case anyone else watches this video back, I do want to make sure that we're going at a good enough pace that they can also learn from it. So we'll try and move quickly, but I don't want to move too quickly to the point where we're just whizzing through the paper, because then, not necessarily everyone can get benefit from that. Let's move on to question C. Figure 5 shows a graph of the relative strength of aluminium-magnesium alloys when the percentage by mass of magnesium in the alloy is changed. So you have a bit of a graph there. Describe what figure 5 shows about the relative strength of these alloys when the percentage by mass of magnesium changes. We have a bit of a describe question. Okay, what do we think here? What I'll do is I'll move the page back to the graph so we can see the graph in case it helps us answer this question. So the x-axis is percentage by mass of magnesium in the alloy, and the y-axis is the relative strength of the alloy. Okay, so we have a bit of an answer here. When there is a gradual increase of percentage by mass of magnesium in an alloy, the relative strength of the alloy increases. Okay, I would definitely agree with that. There seems to be a proportional relationship between the two. So strength increases as percentage of magnesium by mass increases. Other things you could say here in the mark scheme include saying that it's linear. You could also say that it increases from 0.1% to 3.5%. So ultimately what I would say with these graph questions as well, if there's ever scope for you to sort of throw in some examples of numbers in there, that can also get you marks. So definitely do that. Oh, hi Solomon, good to see you. Thanks for joining the live stream. Hope you're well. Great to see you today. So let's move on to the next question. Part 2 actually. Determine using figure 5 the percentage by mass of aluminium in an aluminium-magnesium alloy with a relative strength of 103. So again, I'm going to put the graph there. Okay, so here we want to find out what the relative, the percentage by mass of magnesium is when the relative strength is 103. I'll give you guys a couple of minutes to calculate that. So, okay, so Mohammed, you've gotten 3%. Excellent. Solomon, if you do have a chance, do answer as well. What answer did you get? It'd be great to see whether you also got 3%. If you don't get a chance to answer now, don't worry, that's fine. But yeah, 3% is the correct answer. Okay, so with this type of graph question, it is just a case of finding the point that you want to read off of on your y-axis, getting it to intersect with your line, and then moving down to the x-axis and reading off the axis there. Okay, fantastic. Okay, question D. Metal objects can be electroplated with gold. Give 2 reasons why metal objects are electroplated with gold. So 2 points here. Let's see what we can come up with. So what are some ideas? Why do you think we gold plate metals? Okay, so Mohammed, you've said so it doesn't react with oxygen, and electroplating gold is easier because it's less reactive. Okay, okay. So let me address the first. So the first point I would say is correct. I guess the aim here really is that it doesn't necessarily react with anything else. I wouldn't necessarily specify oxygen because reactivity can be with anything else. So a metal can react with, we know that metals can react with water as well, depending if it's an alkali metal, for instance. So I would definitely say that we want to sort of reduce reactivity. I think with the second point, where you've said electroplating gold is easier because it's less reactive. What I would say is, whilst that might be true, I don't necessarily think that quite answers the question. The question itself wants us to think a bit about why we electroplate objects with gold. And I suppose saying that electroplating with gold is easier because it's less reactive, I wouldn't say that's necessarily a reason for electroplating with gold. I think one of the key things is that electroplating with gold can give you a much greater appearance. So if you want something that's gold plated or silver plated, it means you get that nice appearance for the object, but the entire object itself isn't gold or silver, which may be cheaper to the manufacturer. And if we have a quick look at the mark scheme, that's sort of the angle that they were going for. So one mark for sort of pointing out that, electroplating with gold is, given much nicer appearance, but also it then results in, less reactivity. Okay, and that works because gold is very unreactive. So we have this nice sort of layer of unreactive coating around the metal in question. Okay, so that's what I would say for that question. All right, let's move along to question 5. This one is about electrolysis. So a sample of molten potassium bromide is electrolyzed. What are the 2 products formed? Now, what I'm going to do after part B as well is just go over a quick little whistle-stop tour on electrolysis, because we've talked a bit about electrolysis before in this chemistry squad series, but I do want to use it as an opportunity to talk about it briefly again, because I know it's always a bit of an issue. It's a bit of an area where a lot of students can lose marks. So what do we think? A, B, C, or D? What do we think the reactants are when we electrolyze molten potassium bromide? Okay, so we've said B there as our answer. Okay, so interestingly enough, the correct answer here actually would be D. Okay, and it's actually interesting. The reason that I want to talk a little bit about electrolysis is situations like these, where one of your options is just the different ions, and another option is where you might have one ion in hydrogen gas or one ion in oxygen. Okay, when it comes to electrolysis, there are two separate circumstances. One in which is molten, where you just melt down the substance. The other is when you have your ionic substance dissolved in water. Now, in a molten scenario where you have a molten ionic compound, electrolysis is generally quite straightforward because you only have the two substances. So in this instance, because I have potassium bromide and it's molten, the potassium bromide just breaks down into potassium ions and bromide ions. So I know that my potassium cations are going to go to the cathode to form potassium, and then my bromide anions are going to go to the anode to then form bromine gas. So that's not too bad. That's quite easy to get your head around. When you have a molten substance, it's quite binary. It's one or the other. So you only have two ions in that respect. But when you have an ionic compound dissolved in solution, it's a little bit more tricky, okay? And the reason it's more tricky is because now you've got your ions in solution, you can also, when you electrolyze this ionic solution, water into hydrogen ions and hydroxide ions, and that's the challenging thing, okay? So in that situation, you have your hydrogen ions and you have your metal ion, so your cation. You also have your non-metals, so you have your hydroxide ion and the non-metal in question. And then it's a case of, well, what do I form at each electrode? It's a really, really easy way to remember this. And actually, we talked about this in our electrolysis chemistry score session, I think maybe 2 or 3 weeks ago. So do check out that earlier YouTube video on this channel if you want a bit of a refresher. When you're looking at the metals and your hydrogen, so the cations, if the metal is more reactive than hydrogen, then the metal stays in solution and you form hydrogen at the cathode. I'll say that again. If the metal is more reactive than hydrogen, then the metal stays in solution and you form hydrogen at the cathode. And conversely, if hydrogen is more reactive than the metal, then the hydrogen stays in solution and the metal is formed at the cathode. Conversely, if you look at the non-metals, even easier. Essentially, if you have an ionic compound in solution, you will always form oxygen apart from if you have a halide in there. So if you have one of the group 7 non-metals, so either fluorine, chlorine, bromine or iodine, you'll always form oxygen at the anode if you have an ionic compound in solution, so dissolved in water. Okay, but if you have one of those halogens, you will always form the halide at the anode. Okay, so that's what I would say with respect to that question. Okay, fantastic. Electrolysis can be really, really difficult to get your head around, so if it's something that you struggle with, do make sure to go over it again. Okay, and let's look at question. So the correct answer here was D. Okay, so D was the correct answer. So you only form potassium and bromine. So can we skip electrolysis and do other questions because I haven't done electrolysis in school yet? So don't really want to skip through the paper. What I will say is at the end of the session, I'll signpost you to where you can access this paper. So if you want to go over it yourself and maybe try different questions, skip certain things, then by all means, you can do that independently. I just want to make sure that we go through this paper chronologically so that maybe if a year 11 student goes over this and they have gone over electrolysis, we don't skip that section, okay? But I will show you where to access this paper, so by all means you can try some other questions if you'd like. So, we'll just go over part B really quickly. What I'll do is I'll sort of talk through this question because I am also aware that we are cutting into Q&A time. Zinc chloride and zinc carbonate zinc chloride and zinc carbonate contain ions. Zinc chloride mixed with water can be electrolyzed. Zinc carbonate mixed with water can't be electrolyzed. Explain the difference. This would be because zinc chloride is soluble in water, but then zinc carbonate is not soluble in water. So this is part of the course where you learn about the different compounds and their trends. So because zinc carbonate doesn't dissolve, okay, it's not soluble, it can't break down into its individual ions, which means that you don't have free moving ions to carry a charge. That explanation will sound very, very similar to what some of you may have learned with regards to ionic compounds as well, where we learned that ionic compounds in solution can carry a charge, can conduct electricity because the ions are free to move around. So what you've seen there actually is a good example of where a lot of different parts of the course actually overlap with each other. So do make sure to know those fundamentals, especially as you go from each subject or each topic to the next topic to the next topic. Okay, so that would be your answer to part B. And part C. In the electrolysis of sodium chloride solution, bubbles of a colourless gas form at the cathode. This gas, when mixed with air, burns with a squeaky pop. Identify this gas. So this gas would be hydrogen gas. So hopefully you will know that in terms of identification for your different substances, hydrogen is identified with a squeaky pop if you were to put a lit splint next to it. In terms of why this gas is formed at the cathode, so this is, this sort of echoes what I said earlier. So your hydrogen ions are going to be attracted to the cathode, okay, and your hydrogen ions then undergo reduction at the cathode, and you end up forming hydrogen gas. And the reason that we form hydrogen rather than sodium is because sodium is much higher up your reactivity series than hydrogen. The hydrogen is formed at the cathode rather than sodium. Okay, fantastic. Let's move on to... We'll move on from part D because drawing is a little bit difficult because it makes it lag. So let's move on to question 6. So we'll just do 6A part 1 and maybe 6A and B, and then we'll just go into a quick Q&A session, and then we'll finish up, and I'll give some last minute advice as I close this chemistry squad for this academic year. So 6A, copper carbonate reacts with dilute nitric acid. During the reaction, the copper carbonate powder completely disappears. State what can be deduced about the amount of acid used. So what can we say here? What can we deduce about the amount of acid used if, in this scenario, the copper carbonate powder completely disappears? There's a word that we would use here, a word beginning with E. What do we think it is? I'll give you guys 2 minutes to sort of think of an answer. If not, no worries at all. These sessions are here for you to learn. So if you don't know, we will go over it anyway. We'll just give it 1 more minute. So when we get to 6:37, we will go through the answers. Okay, I'll tell you what. We'll move on to the answers then. Absolutely fine. So, if you have if you have an acid and a base, this is what we've got here. You have your carbonate as your base, and you have your nitric acid. So the fact that the nitric acid, okay, has been added to this copper carbonate, and the copper carbonate dissolves entirely, that would imply that the copper carbonate has reacted entirely with acid, so the acid must be in excess. We must have added sufficient acid in order to dissolve the base, for the base to react. So that would imply that the acid is in excess in this question. Okay, let's move on to part 2. During the reaction, the pH of the mixture changed from 2 to 6. By what factor has the concentration of the hydrogen ions in the mixture changed? A, B, C, or D? This is always a bit of an interesting one. The correct answer here would be D. Okay. Now, the pH scale is logarithmic, so it always goes up in factors of 10. So 1 unit, so let's say 1 to 2 or 2 to 3, is 10 worth. So if we've said that the pH has changed from 2 to 6, that is 4 tens, so that would be 10,000. And because it's gone from 2 to 6, we know it's become more alkaline. Okay, it's becoming less acidic. So actually, that would imply that the concentration of hydrogen ions has gone down by a factor of 1 over 10,000. Okay. Again, remember that a lower pH means a higher concentration of hydrogen ions because it's more acid, it's more acidic. A higher pH would imply fewer hydrogen ions, it's less acidic, it's more alkaline. Okay, and then part B we'll finish off with for today. Using different reactants, a solution of copper sulfate was prepared. Describe what should be done to obtain copper sulfate crystals from this copper sulfate solution. This is a really common question with GCSE chemistry. They always love asking questions about copper sulfate crystals and how you would form them from the solution. Sometimes they are 3 markers, sometimes they are 5 markers. In this instance, it is just a 2 marker, so that's not too bad. Okay, so in your description, the key points that you would add here is that you would probably heat the solution really slowly until maybe half the volume has evaporated. Okay, and then you leave it to cool, for instance. Okay, and you might want to pat the crystals dry afterwards, or maybe dry them in an oven to remove any excess water. Now, the reason I say you want to dry it slowly is because generally drying the solution off slowly for evaporation means you get much larger crystals being formed. Okay, so that's what I would say with respect to that question. And I think with that, that sums up the active teaching part of today's session. So what I'm going to do is I'm going to move over to the Q&A section. So if anyone has any questions at all about chemistry or about GCSEs in general, revision, etc., then we've got 5 minutes or so just to ask any last minute questions. And if not, what I'll do is I will just give you all some advice moving forward, whether you are watching this in year 9, whether you're watching this in year 10, preparing for year 11, etc. So, I think the bit of advice that I would give you all is that remember that your GCSEs are a marathon, okay? I know you've probably been told this umpteen times before. You do not want to leave your revision to the last minute, okay? Now, that doesn't mean that you're doing ridiculous all-nighters, for instance, and studying, really late, because it just doesn't work, okay? You can't retain information, you're tired the next day, and then you can't really learn as much as you'd like to. What it does mean, though, is you take ownership of your learning. So let's say, for instance, electrolysis, you go over it in school and you realise, actually, I don't really understand electrolysis. Instead of putting it to the side and saying, okay, I'll deal with it later, what you then do is you take ownership of it and you say, okay, I don't understand it, but this is what I'm going to do to make sure I understand it. There are some really good YouTube videos out there that sort of explain electrolysis and other sort of concepts like that. There are loads of notes that you can find online. I've already mentioned physics and maths tutor, but there are also other websites like Save My Exams, and I'm sure you can find loads of other resources out there that you can utilize. And that's not even mentioning your own exam board's revision guide. Okay. So I would say just take ownership of that and make sure that you revise diligently over a much longer period of time rather than trying to cram everything into the last minute. Okay. So that's one bit of advice I would give. Another thing that I would say, okay, if you have the opportunity to ask your teachers for help, then do so. Okay, they are there to help you. We at My Tutor are also here to help you. So if you do have any questions, you can always message the My Tutor team. And if you do feel like you need further tuition, then the My Tutor team can always pair you with someone that they feel as though might be a good fit for you. All of us here at My Tutor were all interviewed, and only 1 in 8 of us actually become tutors, and we're all picked from really good institutions. So whether you have one tutor or another, I have no doubt that you'd be supported throughout GCSE, whether you decide to have tuition for the whole academic year, or whether you decide just to have a few lessons here and there, depending on what you feel you need as a student. Okay. Don't be afraid to make notes as you go along. Do make sure to do past paper questions and just get practice with them. Okay. And what I would say is just utilize the time that you have. Okay. You only get one shot to do GCSEs really. Okay. And then A-level swings around really quickly. But otherwise, what I would say here is just enjoy the process. And I know that might sound really weird. but do enjoy it, okay? Enjoy the learning and enjoy the satisfaction that comes out of getting your aspirational grade, and I'm sure all of you will go on to sort of achieve that. So, that is it for me. Well, that is it from me anyway. As I mentioned before, any feedback that you can give us at My Tutor is really, really useful, because it means that we then know what you like, it means we know what you don't like, and it means that we can then take that away and we can use it to put together more resources that can support all of you. Okay? Again, make sure to like this video if you did like it. And make sure to share it with others if you think they might find it useful. Okay. Um, there may be other study squads in the future, next academic year. Again, not entirely sure, but the more feedback we get, okay, the more it lets us know what exactly you want out of these sessions and how you want them to be structured. Okay. I remember the first time I did these squads, it was an hour session. Then the next time I did them, it was half an hour, and now we're at 45 minutes. So you can see that we do listen to your feedback, we take it on board, and we mold it into what you find useful as students. Okay. But otherwise, it's been absolutely lovely being your chemistry tutor for this academic year. This was actually the last chemistry squad of this term this year. Do enjoy the summer. Okay, take a good earned break, whether you are going abroad, whether you are staying home. But just take a break and sort of, revitalize yourself in preparation for the next academic step. Whether you're in year 9 going into year 10, whether you're in year 10 going into year 11, or in the off chance you're in year 11 going into year 12. You never really know. But do make sure to revitalize. But otherwise, I'm NK. One more question actually from Mohammed. What happens if the college doesn't accept you and then you get good grades? That's a very good question. I actually have in my first ever squad, I went through the university process. That's one of the sessions. I think it was a 2-part one. But I'll answer the question now anyway. So, the way your university admissions works in the UK is you use something called a UCAS, where you will do a personal statement. It's only one personal statement for you as an applicant, and you will pick 5 different universities to apply to. Okay. Now, let's say, for instance, you apply, and let's say you're given aspirational grades, and between those and your personal statement will determine, and maybe an interview will determine whether or not the university gives you an offer. Now, the offer will be a certain number of grades. So they might say, you're okay to study chemistry with us, provided that at the end of A level you get 3 A's, or an A star and a B and an A, or something to that effect. Now, this is why when you come to apply for university, we encourage you to pick different institutions with a range of grades. So after you've gotten all your offers back and all your universities have responded to you, you will pick one of them as a firm choice, and that's the one that you will commit to going to if you get those grades on results day. And if you miss those grades, you then go to your insurance, and your insurance will accept you. But then there's no point in having an insurance that has the exact same grades as your firm, because if you don't get the firm grades, and you see where I'm going with this. So let's say, for instance, you're unlucky and your universities that you picked don't give you any offers. If you still get good grades at the end of A-level, there are 1 or 2 things you can do. You can go through something called adjustment or clearing, where there are still spaces for some university courses that you can apply on the day. Alternatively, if you wanted to, you could take a year out, and then that way, you can have a bit of time to sort of think about what you want to do, and then you could reapply. So you always have options, even if results day doesn't necessarily go the way you wanted it to. So that's what I would say there. But otherwise, I think that's our last session and last question for today's and this year's chemistry squad. So my name's NK. It's been absolutely fantastic teaching you all. Hopefully I'll see you all again next academic year. It may be me, it may be another tutor, but at the end of the day, everyone here at My Tutor is here to support all of you in your academic endeavours. Okay, so I'm sure, if not the squads, My Tutor will put something together that will support all of you that's just as fun and just as engaging. But otherwise, see you all soon. Take care of yourselves. Have an absolutely lovely summer, okay? And all the best with your academics in the future, okay? But take care until then.